In the previous episode I demolished the old shed, and in this video I'm going to start making a floor for the new shed utilising an existing concrete foundation where our greenhouse used to be. First I needed to decide on how to construct the floor, and I thought about this quite a lot and came up with a number of different options, each with their own advantages and disadvantages, which I'll talk through now. Here you can see a scale drawing of the existing concrete base. The first option would be to dig the soil out, lay about 75mm or more of hardcore as a sub base for the floor, compact it all down nice and firm, and then mix up some concrete to lay about another 75mm of concrete inside the existing foundation and screed it over nice and smooth with a length of timber. That would definitely be the best option for a floor here. It'd be the most durable and longest lasting. It would also be the most expensive option, probably looking at around £150 for all of the materials and ingredients for the concrete. But the biggest problem with that option was that I'd need to move between 2.5 and 3 tons of gravel, sand, cement and hardcore from my front drive to the very back of my garden, which is about 45 metres away, using a wheelbarrow, and I'd also need to navigate these steps too. So I had to rule that one out really quickly, even though it would have been really nice. The second option was to dig out the soil to create space for ventilation underneath the new shed, and then use 8 2.4 metre lengths of tannalised or pressure treated 6x2s or 150 by 47mm timber, which would offer enough structural strength for the span of the width of that concrete foundation, which measured about 2.3 metres. And I could add 2 3.6 metre lengths of timber along the length of the foundations to add more rigidity and also cover the end grain of the 2.4 metre lengths to protect them from moisture. And I could add noggins in between the joists for more rigidity. There were 2 problems with that option though. One, sheds need good ventilation under the floor, as you don't want to trap moisture because that can create issues with mould. So I'd need to drill loads of holes and possibly add some vents to help the air flow through underneath the shed. The bigger issue though is that I'd already designed my shed, and I designed it based on using standardised timber dimensions to minimise the amount of work involved making cuts and that kind of stuff. And because the framing, cladding and sheet material that I'll be using for the width of the shed comes in 2.4 metre lengths, the shed wouldn't be wide enough to span the full width of the floor structure, which would mean those long edges would be sticking out and exposed to the weather. As it's pressure treated, it would probably still last many years, but it was enough to put me off the option, so I decided to have a rethink. I decided that I could forego those longer timbers and just use the 8 2.4 metre lengths across the width of the foundation and lay the floor on top of that. That would provide much better ventilation under the shed, and I wouldn't need as much timber, so it would cost less. And this is kind of what I ended up doing, but with a few differences which I'll cover later in the video. So I started removing the old paving slabs and the soil, and most of the slabs were just laid directly onto the soil, so they were easy enough to shift out of the way. However, I discovered that this row of slabs here was really solid and were laid on a concrete base of their own, and the slabs were also perfectly level with the perimeter concrete foundation. So at this point I decided that instead of buying 6x2 or 150 by 47mm timber, I could save some money and get some smaller 75 by 47mm timber instead, which would work fine because with these slabs in place the spans were much smaller. The perimeter foundation was covered in moss, so I grabbed a wire brush to give it a good clean up. And then I just tipped on some water to clean everything up nicely. With the area prepared, next I laid some weed-proof membrane. Normally I wouldn't have bothered doing this, to be honest, but there was a roll of it kicking around left by the previous owners, so I figured I may as well make use of it. But as it happens, unfortunately there wasn't quite enough to cover the whole floor anyway, but I guess some is better than none. I used some rubble just to hold it down in place. I went to a local sawmill to get the timber, and this tannalised timber is available in either green or brown, but they didn't have any green in stock, so brown it was. I picked up a roll of damp-proof coarse plastic, and I can use this to protect the end grain of the timber, which typically soaks up moisture quite a lot, hence trying to protect it a bit. I unrolled it, and then I could fold it up over the end grain of the timber and staple it in place at each end. This DPC is also going to protect the underside of the wood from any moisture rising up through the ground and into the slabs or concrete. Unfortunately, the slabs that were there didn't cover the full length of the foundation, so I'd need to add a slab at the end to fill the gap. I started by compacting the soil as much as possible using a concrete block, and then I mixed up some sharp sand with a little bit of cement, I'm guessing the quantities here are probably about 4 parts sand to 1 part cement. I added a little water, but not much, as it needs to be a relatively dry mix from what I've heard anyway. I'm just taking advice from my dad on this one. I compact it down as much as possible, and then I can place the slab on top to see how it's looking. And it took a few attempts to get this slab nice and level with the other slabs and also the perimeter foundation. I just used a relatively straight piece of timber to check it for level. I got there in the end. Next I'm going to cut some noggins to reinforce the floor structure, and to work out the length of those, the way I do it is to take the length of the shed, which is going to be 3.6 meters, minus the width of all of the timber joists, which each measure about 47 millimeters, and there's 8 of those, which is 376 millimeters. So that's 3,224 millimeters, and then I divide that by the number of spaces in between the joists, which is 7 in this case, and that gives me 460.5 millimeters. I cut the noggins using my circular saw with a speed square guiding the cut. This method works great, it's quick and it's plenty accurate enough for a carpentry job like this. I'm going to add a couple of noggins in between each of the joists on either side of where the slabs are, and this will help to strengthen the floor structure, making it more rigid, and also it keeps the joists spaced evenly apart. And I can use my framing nailer with some 90mm nails to secure them in place. I think this is only the 4th time that I've used this framing nailer, as this isn't the kind of work that I normally do, but whenever I do get to use it, I really enjoy it. It's a great tool. You might notice here that I'm not really worrying too much about how square the floor assembly is at this point. As long as it looked roughly square by eye, that's all I need to know at this point, and there is a reason for that, which I'll talk about later on. As you can see, the positions of each noggin are alternated and staggered to allow access for the nails to go in. Before adding the final 2 noggins and before cutting them to size, I take a quick measurement just to make sure that I'm on track to achieve the 3.6 meter length. Okay, so this is my 3 meter mark here, so I need this measurement to be 600 mil. So this needs to move this way, and now I can measure the distance between, which is 459. So then I cut my final 2 noggins at 459mm rather than 460.5mm. Not that that 1.5mm is really going to make any difference here at all, but anyway. I'd need some 18mm thick sheathing for the floor, and I was planning to use some second-hand salvaged plywood which I'd spotted earlier on Facebook Marketplace. But when I needed it, it was no longer there, and I wanted to crack on with the build, so instead I opted for some new sheets of 18mm OSB from my local builder's merchant, and I needed about 3.5 sheets for my floor. The weather took a turn for the worse, so I covered the OSB with a tarpaulin to keep it dry, and that was all I could get done on day 2 of the build. Day 3 was glorious though, so it was a good excuse to get my lucky shorts on and listen to some good tunes. Here I'm measuring from the end joist to the centre of the 3rd joist in, and then I can mark up where to cut the first sheet of OSB. I set up the track saw to rip the sheet to size. Because these OSB sheets measured 2,440mm, the equivalent of 8 foot, I also needed to trim off 40mm from the length in order to match the 2.4 meter length of the joists that I'm using here. Then I can start securing the OSB down to the joists, and first I add screws all along the short edge, and then I can use the factory edge of the plywood to square up the joists beneath. Hopefully you understand what I mean. Basically, because the floor structure is held in place with nails, the frame has a bit of movement in it, and that allows me to square it up to the OSB, and then everything is good and square. And then I can add more screws. Here I'm marking up where the centre of the noggins is because I could remember those measurements that I used. And I added screws there too. and also to that joist in the middle, and by this point the floor is nice and rigid. The next sheet would need to be cut slightly smaller than the first, as it needed to span from the centre of a joist to the centre of another joist. And after cutting that to size, I can secure that down in the same way as before, again squaring up the frame of the floor to the OSB. And here I'm just adding the last piece, which just needed to span those end two joists. One last thing I wanted to cover in this video is protecting the edges of the OSB from moisture. I did film some footage of me talking about this, but there are a few things to explain here. First, it seems my microphone wasn't plugged in properly, so I'll try and explain this again. Secondly, don't look at those wall frames sitting behind me, as that will be covered in a future episode. And thirdly, no, that's not a moustache, it's dirt. So the OSB that I bought for the floor isn't waterproof, but OSB is generally quite water resistant anyway because of the resinous glue that is used to hold all of the strands of wood together. So I wasn't too worried about the faces of the OSB, but I was a bit worried about the edges where the sheet had been cut to size, because those edges are going to be in contact with the cladding that I'm going to add later onto the side of the shed. And as moisture trickles down the building, the cladding at the bottom is going to be the slowest to dry out. And I was worried about the moisture soaking in through to the OSB edges. I considered using more DPC plastic wrapped around the edges, but I didn't have enough left, and at the time I couldn't find any in stock locally to me either. I did, however, have half a can of this bitumen waterproofing paint left over from a previous project, so I decided to paint some of this onto the edges, and I didn't need to do this neatly at all because it's eventually going to get covered over by the frames of the walls and the cladding. So I painted it on, really trying to work the paint into the end grain as much as possible. I also painted the end face of the floor joists, and I did that mainly because I accidentally spilt some paint on it. A few days later though, I happened to come across a photo of a rotten OSB shed floor online, and you can see here that moisture has soaked into the edges, rotting it away, and that made me decide to actually get another roll of DPC to use here and use some of that, which means I needn't have applied the bitumen paint, but I thought I'd better explain my decision making process here. If you have any questions about this project, please leave them in the comment section below, as I'm thinking of doing a Q&A video towards the end of this series to cover all of the questions. Please subscribe to my channel for more weekly woodworking videos. If you'd like to help support the channel, you can do that via PayPal or Patreon. Links to both of those are in the description box below. And on Patreon you can get early access to my videos, including this series, some exclusive content, free project plans and cut lists, and a name credit at the end of my videos. Thank you for watching.